Hello, my name is Andrew Nairn, and I'll be presenting Design Phase 2 for Team 15, our product being the Mixologist Mixed Drink Maker. What you can expect to see from this presentation, among other things, is a functional decomposition, a concept generation, as well as a gallery method of results and feedback that we got from our fellow design teams, a concept selection alongside screening and scoring process, and then eventually a final design. This is our mission statement, which was decided upon in Design Phase 1, which has led us down the path that we are now. It includes, say, primary markets or college students, a secondary market, stakeholders including the team as well as VTEPs, and a product description and a benefit proposition. Established customer needs also had defined our path in which we needed to take to decide on key design factors of the product, such as expected price range, weight and dimensions of it. Our functional decomposition can be simplified here, in which two inputs, of one being energy and the other being drink selection, which the drink selection will receive the user input in the form of, say, a button or a knob. The energy will be received by the device to power it, and the two will be combined together to convert the electric signal to power the solenoids, and the user input will input the amount of alcohol and mixed drink into to combine the two together in proportions of, say, a single, double, triple, or even a virgin drink, and it will then pour the drink for the user, and the user could be on their way at their social function or party or what have you. This is our 6-3-5 brainwriting method, in which 6 users, or in our case 3, of the team come up with 3 different designs in 5 minutes, and then switch designs and build upon those sub-designs to come up with designs that a single user or a single team member could not come up with on their own, which expands our horizons and comes up with new ideas that we couldn't have come up with on our own. Say, for example, here we have a combination of 2 teammates came up with here, in which 4 outputs were created, so 4 different users could get their drinks at the same time as opposed to 1 at a time. Here's our concept combination table, in which our 2 final designs are displayed here in red and blue as a combination of our 3 subfunctions that are defined in our gallery method, which we'll go over soon. A mind mapping can be shown here, in which the 3 subfunctions are broken up into multiple ancillary subfunctions, in which, say, user control in the form of buttons, switches, and knobs, a liquid storage here, in which, say, the original vessel, or, say, an overhead tank where you have to pour the drink into the tank, and the output method, in which the device interacts with the Arduino and decides the amount of proportions based on an electrical or mechanical output. Here's our gallery method, in which we came up with and got feedback from our fellow design teams in class. Here you can see our 3 subfunctions broken up into 4 different solutions, as well as 6 viable final design solutions as a combination of the 3 subfunctions. Our final design here is a mock-up based on the concept combinations and the feedback, as well as the mind mapping and 6-3-5 method. The chosen subfunctions for this first design, or final design, were a knob input, in which they select a single, double, or triple shot, a combination of solenoid outputs, which we had ended up deciding upon to use in both final designs, as it would be the easiest to interact with the Arduino, and a combination of overhead tanks in the original vessel, say like the vodka bottle or the rum bottle that it comes in when you buy from the store. Our second final design, based on the concept combination table and the feedback as well, includes the 3 subfunctions, which are broken down into the buttons, which you can see here as a single, double, triple, or even virgin option. This one we had decided as our final design, which we ended up making a mock-up of, because it uses 4 overhead tanks as opposed to the combination of the original vessel and the tanks, because it ended up just being easier and more user-friendly. As I said before, we use solenoid outputs for both because it would be the easiest in combination with the Arduino. Here you can see our concept screening, in which we took our 5 solutions from the gallery method. Here at the bottom is a combination of our subfunctions, and you can see the weighted descriptions as well as whether or not we should continue with this viable solution or not. And here you can see our rating as the selection criteria, including sleek aesthetic design, easy to use, communicates the amount of alcohol, a price range, and the volume of the output into the mixed drink, as well as a physical mass or weight of the entire product. And after ranking the 4 solutions that we had deduced, we came up with solution 1 being the most heavily weighted, which ended up being this final design 2 here, which is a combination of the buttons, overhead storage, and the solenoid outputs. The next steps in our design phase 3 will be to finalize product development, reduce manufacturing costs, and possibly our bill of materials, depending on where we decide to get our materials from and if we can cut costs if at all possible. And then after we've done our mock-up design, we'll then begin to develop a prototype, which will be a working model of what we would hope the product to be in the future. Any questions?